Hello everyone, my name is Saurabh Singh and today I am going to teach about the high grade concrete. This is from unit number 5th and this is lecture number 29. After watching this video, if you have any doubt, you can contact to me and you can also write an email on saurabh.singh@mygyanbihar.com. Come on the learning objective and learning outcome. Here you will know about the high grade concrete and you will also know about the lightweight concrete, how it is used in the structure. In learning outcome, you will able to learn and you will able to know about the high grade concrete and you will also see how to use it in the structure. Now we will see the form of prestressing steel. First is wire, which is prestressing wire in a single unit made of steel. Straight, there is two or three or seven wire are wound to the form of prestressing straights. And there is also tendon. It is a group of straight or wire are wound to the form of prestressing tendon. There is cable, a group of tendon from a prestressing cable. Bar, a tendon can be made up by the single steel bar. The diameter of bar is much larger than that of a wire. Now we will see the bonded tendon. When there is adequate bond between the prestressing tendon and concrete, it is called bonded tendon. Pretensioned and touted post-tension tendon are bonded tendons. Now we will see the unbonded tendons. When there is no bond between the pre-stressing tendon and concrete, it is called unbounded tendon. When grout is not applied after post-tensioning, the tendon are unbounded tendon. Now we will see the stage of loading. The analysis of pre-stress member can be different from the different stages of the loading. The stages of loading are as follow. First, we can see initial. It can be subdivided into two stages. First one is during tensioning of steel, and B is also given here a transfer of pre-stress to concrete. Now, intermediate, this include the load during the transportation of pre-stress member. Now come on the final stage, it can be subdivided into two stages at service during the operation and ultimate during the steam event. Now we will see the very important topic here of prestressing. We will see what are the advantages of a prestressed concrete. So, first one is here, section will remain uncracked under the service load and high span and depth ratio are possible in this prestressed concrete and suitable for the precast construction. As we saw, many structures are precast on the other side and they are assembled on the site. That is a precast construction. And metro is also one of the type of precast construction. Now we will see the limitations of prestressing. There is also many limitations of prestressing. Prestressing needs skill technology, hence it is not as common as reinforced concrete. The use of high strength material is costly. There is additional cost in the auxiliary equipment. There is need for the quality control and inspection. Types of prestressing here, external or internal pre-stressing here, pre-tensioning and post-tensioning in here, and one more is linear pre-stressing. These are the types of pre-stressing which is used in the casting of the PSC member. Now we will see the circular pre-stressing. This is the example of a dome which you can see here on your picture, that is circular pre-stressing. Now full limited or partially limited partial pre-stressing is also a method of doing the pre-stressing of concrete, and there is one more anaxial and biaxial or multi-axial pre-stressing which is also used in the preparation of concrete member. So first we will see what will be the definition of pre-stressed concrete. And here is a definition given. Internal stress are induced in the member of counteract and counteract the external stress which are developed due to the external load or service load. That will be your pre-stress. Now, as you can see in this figure, there is one beam of RCC reinforced, which is known as reinforced cement concrete. And if load will be came on the upper side of this beam, then here will be one bending, and this bending will create some cracks in the bottom of this beam, and that's why it is not. That's why here crack will be developed due to the extra load and dead load, and it may be also developed during the service period of this member. And now, if you can see, there is a pre-stressed concrete, and before the applying on this load, there is also pre-stressing tendon, which will react as like a hogging. Your beam is reacting here like a hogging. When load will be applied on it, it will came in this direction, means it will came in a straight position. And there you can see there is a hogging. And there is sagging, and due to the sagging, there is some cracks which are developed in the bottom of this beam. And this is your pre-stress beam, and this is your RCC beam. And as you can see, on same load, what will happening in the RCC beam? There is no any crack. Sorry, in pre-stress beam there is no any cracks, but you will see RCC beam there is a cracks. Now we will know what is the concept behind the pre-stress concrete. Prestressed concrete is basically concrete in which internal stress of a suitable magnitude and distribution are induced so that the stress resulting from the external load are counteracted to a desired degree. And here we will see what are the terminology of pre-stressed concrete. First, we will see the tendon, and tendon is also a material which is used in the preparation of pre-stressed concrete. As you can see, a stressed element used in a concrete member of a structure to impart pre-stress to the concrete. Now, as you can see, this is your tendon, and this will be your PI, and this will be PI. What will happen? And first, you have to apply tendon in the middle of the this section, and then what will happen? It will be elongated by the delta ES and encourage a device generally used to enable the tendon to impart and maintain pre-stress in the concrete. Now, further pre-stress is divided into two parts. Further pre-stress is divided into two parts. First one is a pre-tensioning, second one is a post-tensioning. And these are the, you can also say these two methods are used in the preparation of the concrete. Now, first we will see the pre-tensioning, a method of pre-stressing concrete in which the tendon are tensioned before the concrete is placed. In this method, the concrete is introduced by the bond between steel and concrete. And post-tensioning, a method of pre-stressing concrete by the tensioning the tendon against the hardened concrete. In this method, the pre-stress is imparted to the concrete by the bearing. Now we will see what kind of material we use for the pre-stressed concrete. First, you can see we are using here cement. The cement used the cement used should be any of the following. Like you can use here ordinary Portland cement conforming IS 269. You can also use Portland slag cement by conforming IS 455, but the slag content should be not more than 50%. You can also use the rapid hardening Portland cement conforming to the IS 8041, and here is one more material and one more cement which is known as high strength ordinary Portland cement conforming IS 8112. Now we will see the concrete, pre-stressed concrete. Pre-stressed concrete require concrete which is high compressive strength, reasonably early age with the comparatively higher tensile strength than the ordinary concrete. The concrete for the member shall be air entrained concrete composed of Portland cement, fine and coarse segregated admixture and water. The air entraining feature may be obtained by the use of air entraining Portland cement or an approval of air entraining admixture. The entrained air content or the entrained air content shall be not less than 4% or more than 6%. Minimum cement content we use for the pre-stressed concrete is 300 to 360 kg per meter cube is prescribed for the durability requirement. The water content should be as low as possible. Now we will see what kind of steel we use for the pre-stressed concrete. High tensile steel, tendon, strand or cables. The steel used in pre-stressed concrete shall be any one of the following. First one is given here, plain hardened drawn steel wire conforming IS 1785 part 1 and part 3. Cold drawn intended wire conforming IS 6003. High tensile steel wire bar conforming IS 2090. Uncoated steel relieved strike conforming IS 6006. Now we will see what will be the carbon content and what should be the carbon content and magnesia content and silica content in the steel. It should be between zero point 0.7 to zero point 0.8 carbons, 0.6% magnesium and 0.1% silica. Now we will see the durability, fire resistance and cover requirement for PSC member. And you can see here sometimes we use PSC means pre-stressed concrete member according to IS 1343/1980. These are the some requirement which we have to fulfill during the casting of a pre-stressed member, which is very important in the view of durability, fire resistance, and which will if you will use these method, your concrete will be more durable and it will be fire resistance. So some points are given here. We will see one by one. 20% cover for the pretension member, 30 or size of cable which is ever is bigger for the post tension member. If the pre-stress member are exposed to an aggressive environment, these cover are increased by another 10 Now we will see the necessity of high grade of concrete and steel. What is the reason behind it? Why we need to use higher grade of concrete and higher grade of steel in the preparation of pre-stressed concrete? As you can see here, the higher grade of concrete higher the bond stress, which is vital, and pre-tension concrete. Also higher bearing strength, which is vital in post-tensioning concrete. Generally, minimum M30 grade or M grade M30 grade of concrete is used for the post-tensioning and M40 grade of concrete is used for the pre-tensioning. These types of questions have been came in the many government exam. What is the minimum grade of a concrete for the pre-tensioning and post-tensioning? If there will be post-tensioning, then you can answer M30 grade of concrete is a M30 grade of concrete is the minimum grade for the pre-stressed concrete in the post-tensioning method, and M40 grade of concrete is the minimum grade of concrete which is used in the pre-tensioning method. Now we will see the history and development of pre-stressed concrete. And here metal bands are showing one. This is wooden barrels, force filling of metal, and there is some metal bands which is resisting which is resisting and which is also you can say countering the stress which is hoop stress uh, which is generating from the liquid. So it will work as a metal band will work as a tensioning member. Now spokes, as you can see in a wheel, bicycle wheel, there is spokes. In a bicycle, it is work as a pre-tensioning. Now form of the pre-stressing steel. Now we will see the source of pre-stressing force. There is hydraulic pressure, pre-stressing, and electrical pre-stressing and mechanical pre-stressing. Now we will know differences of pre-stressing concrete over reinforced concrete. In pre-stressed concrete member, steel plays active role. The stress in steel prevails whether external load is there or not. But in RCC, steel plays a messy role. The stress in a steel RCC member depend on the external load. No external load, no stress is required for the steel. In pre-stressed concrete, the stress in steel is almost constant, whereas the RCC, the stress in steel is variable with a lever arm. Concrete have more shear resistance, whereas shear resistance of RCC is less. In pre-stressing, concrete member deflection are less. In pre-stressed concrete, fatigue resistance is more compared to RCC. In pre-stressed concrete, dimensions are less because external stress are counterbalanced by the external stress induced by the pre-stress. Now we will see the analysis of a pre-stress member and what is the basic assumptions. First, we have to assume concrete is a homogeneous material. Second, within the range of working stress, both concrete and steel behave elastic, elastically, notwithstanding a small amount of creep which is occur in both material under a sustained loading. The plane section before bending assume they remain plane even after bending, which implies a linear strain distribution across the depth of the member. Now you can see that is your concentrating tendon, and there is also concentrating prestressing. This is your eccentric tendon. As you can see on this image, there is a beam with the bonded tendon, and it is held by the prestressing force. Now we will see the form of prestressing steel. First is wire, which is prestressing wire in a single unit made of steel. Straight, there is two or three or seven wire are wound to the form of prestressing straights. And there is also tendon. It is a group of straight or wire are wound to the form of prestressing tendon. There is cable, a group of tendon from a prestressing cable. Bar, a tendon can be made up by the single steel bar. The diameter of bar is much larger than that of a wire. Now we will see the bonded tendon. When there is adequate bond between the pre-stressing tendon and concrete, it is called bonded tendon. Pre-tensioned and touted post-tension tendon are bonded tendons. Now we will see the unbonded tendons. When there is no bond between the pre-stressing tendon and concrete, it is called unbounded tendon. When grout is not applied after post-tensioning, the tendon are unbounded tendon. Now we will see the stage of loading. The analysis of pre-stress member can be different from the different stages of the loading. The stages of loading are as follow. First, we can see initial. It can be subdivided into two stages. First one is during tensioning of steel, and B is also given here a transfer of pre-stress to concrete. Now intermediate, this include the load during the transportation of pre-stress member. Now come on the final stage, it can be subdivided into two stages at service during the operation and ultimate during the steam event. Now we will see the very important topic here of prestressing. We will see what are the advantages of a prestressed concrete. So, first one is here, section will remain uncracked under the service load and high span and depth ratio are possible in this pre-stressed concrete and suitable for the precast construction. As we saw, many structures are precast on the other side and they are assembled on the site. That is a precast construction. And metro is also one of the type of precast construction. Now we will see the limitations of prestressing. There is also many limitations of prestressing. Prestressing needs skill technology, hence it is not as common as reinforced concrete. The use of high strength material is costly. There is additional cost in the auxiliary equipment. There is need for the quality control and inspection. Types of prestressing here, external or internal pre-stressing here, pre-tensioning and post-tensioning in here, and one more is linear pre-stressing. These are the types of pre-stressing which is used in the casting of the PSC member. Now we will see the circular pre-stressing. This is the example of a dome which you can see here on your picture, that is circular pre-stressing. Now, full limited or partial prestressing is also a method of doing the prestressing of concrete, and there is one more, anaxial and biaxial or multi-axial prestressing, which is also used in the preparation of concrete member. Now we will see the source of prestressing force. There is hydraulic pressure, prestressing, and electrical prestressing and mechanical prestressing. Now we will know differences of prestressing concrete over reinforced concrete. In prestressed concrete member, steel plays active role. The stress in steel prevails whether external load is there or not. But in RCC, steel plays a massive role. The stress in steel RCC member depend on the external load. No external load, no stress is required for the steel. In pre-stressed concrete, the stress in steel is almost constant, whereas the RCC, the stress in steel is variable with a lever arm. Concrete have more shear resistance, whereas shear resistance of RCC is less. In pre-stressing, concrete member deflection are less. In pre-stressed concrete, fatigue resistance is more compared to RCC. In pre-stressed concrete, dimensions are less because external stress are counterbalanced by the external stress induced by the pre-stress. Now we will see the analysis of a pre-stress member and what is the basic assumptions. First, we have to assume concrete is a homogeneous material. Second, within the range of working stress, both concrete and steel behave elastic, elastically, notwithstanding a small amount of creep which is occur in both material under a sustained loading. The plane section before bending assume they remain plane even after bending, which implies a linear strain distribution across the depth of the member. Now you can see that is your concentrating tendon, and there is also concentrating prestressing. This is your eccentric tendon. As you can see on this image, there is a beam with the bonded tendon, and it is held by the prestressing force. Now come on the losses of prestressed concrete. Prestress does not remain constant with the time, and even during prestressing of tendon and transfer of prestressing, there is no drop in prestress form of the initially applied stress. Reduction of prestress is nothing but loss in the properties of prestress, and loss of pre-stress is classified into two types. First one is short-term immediate loss, which is known as short-term and immediate loss, and long-term time-dependent loss. These two types of losses which occurred in the precious concrete. Now, one by one, we will see. First one, we will see the immediate loss. It occurs during the prestressing of tendon and transfer of properties of concrete member. And there is time-dependent loss which occur during the service life of a structure. Now we will see the immediate loss. What things include the immediate losses in the pre-stress concrete? First one is elastic shortening of concrete. FC is given here, which is known as pre-stress concrete at the level of steel. ES, which is known as modulus of elasticity of steel. EC, modulus of elasticity of concrete, and alpha E means modular ratio. Strain and concrete at the level of steel will be Fc upon EC. Stress in the steel corresponding the strain will be equal to Fc upon EC into ES. Sleep at the anchorage immediate after pre-stressing. The magnitude of loss of pre-stress due to sleep in anchorage is computed as the follow. If delta sleep of anchorage in mm, L length of cable in mm, a cross-sectional area of a cable in mm, ES will be equal to modulus of elasticity, which will be in Newton per mm square. P will be pre-stressing of force in the cable, which will be the unit of P will be Newton here, and we can write delta, elongation delta will be PL upon AES, and hence loss in pre-stress due to anchorage slip will be equal to P upon A equal to ES delta upon L. That is the friction between tendon and tendon duct and the Woodwell effect, as you can see in your figure. And Px is equals to P naught E upon bracket mu alpha plus Kx, where P naught will be the pre-stressing force at the jacking end. M will be the coefficient of friction between the cable and duct. A will be the cumulative angle in radian through the tangent to the cable profile has turned between any 2 points under the consideration. K is the friction of coefficient for wave effect. The IS code recommends the following value for the K. K will be equal to 0.15 per 100 meter for the normal condition, and it will be 1.5 per 100 and for thin wall duct where heavy vibration are encountered and in other adverse condition. Now we will see the time dependent losses. There is relaxation of pre-stress steel. Most of the codes provide the loss of stress due to the relaxation of steel as the percentage of initial stress in the steel. The BIS recommend the value varying from 0 to 90 Newton per mm square for stress in wires varying from zero point 0.5 FPU to 0.8 FPU, where FPU will be denoted as the characteristic strength of pre-stressing tendon. And now this flowchart will show you what is the how we will see the losses in the pre-stress concrete. First one is immediate, and second one is time dependent. And in immediate, it is further categorized into three parts. First one is elastic shortening, friction, and crease slip. And time dependent, in time dependent there is grip loss, shrinkage loss, and relaxation loss. Now come on the flexural of the pre-stress concrete. First, we will see here the similar. It is similar to the member under axial load and analysis of a member under the flexural refer to the evaluation of the following. Some points are given here, which is permissible stress is based on allowable stress at the transfer, stress under the service load. These are compared with the allowable stress under the service condition. Now we will see the ultimate strength. This is compared with the demand under reinforced factor and the entire load versus deformation behavior. Now we will see the assumptions which is related to the flexural strength of a concrete in a pre-stressed concrete. The analysis of member under flexural condition is following. Plane section will remain plane till the failure and known as the Bernoulli hypothesis and perfect bond between concrete and pre-stressing steel for bond tendon. Principle of mechanics is also given here. The analysis involving the three principles of mechanics. First one is equilibrium of internal forces with the external loads. The comparison in steel C is equal to the tension in tendon T. The couple of C and T are equal to the moment due to the external load. And next point is compatibility of the strain in concrete and steel for bond tendon. The formulation also involved in the first assumption of plane section remaining plane after the bending. For the unbounded tendon, the compatibility is in terms of deformation. And the relationship relating to stress and strain in the materials, as you can see, this is the variation of internal force which is which acts in the form of force in the concrete, as you can see here. Now we will see the analysis at the transfer at the surface. It is based on the stress contest concept. It is also based on the force concept, and it is also based on the load balancing concept. And this is based on the stress concept. First one you can see that is showing the internal force in the pre-stressed concrete, as you can see, and this graph is showing for the stress diagram for the stress, and will be equal to Pey upon I, which will be stress due to the Pe, and it will become like resultant stress profile will be like this. And here F will be equal to minus P upon A, P plus minus Ey upon L, and plus minus My upon E. Now we will see the based on concept, force concept here. As you can see, internal forces at prestressing, neglecting self-weight, internal force after the loading, which it is showing there F will be equal to minus P upon A plus minus P Ey upon I plus minus My upon I. Based on the tendon load balance concept, there is a first one is for parabolic tendon, which is here free body diagram of concrete, and second one is a bending moment diagram. And here M will be equal to W UPL square upon 8. For singly hard tendon, it is showing the free body diagram of concrete and bending moment diagram. Here M will be equal to W UPL. Here M will be WU upon L upon 4. It will become PE, and WP is equals to PE upon L. And here all result will be delta is equals to WUPL 48 upon EI. Come on the next, it is showing the free body diagram of concrete, and that is also bending moment diagram, which you can see here. This is your bending moment diagram, and here M will be equal to WP AL equal to PE, and WP will become PE upon AL, and delta, and you can, by this you can determine the deflection of a beam by delta is equals to A 3 minus 4 square WUPLQ upon 24 EI. Now we will see the analysis on the basis of shear. First, introduction. The analysis of reinforced concrete and pre-stressed concrete member for shear is more difficult compared to analysis for axial load or flexural. The analysis for axial load and flexural load are based on the following principle of mechanism. First one is equilibrium. compatibility, and constitutive relationship of a material. As you can see, this is the diagram stress of an cracked beam, which is showing the shear force diagram and bending moment diagram. And this is a variation in the normal stress and variation in the shear stress. This is showing variation of force and stress in a simply supported beam. Now we will see pretension member, the stress tendon transferred, the pre-stress. Pre-stressed member, the stress tendon transfer to pre-stress to the concrete leading a self-equilibrium condition. For a pre-tensioning member, usually there is no anchorage device at the end. As you can see in the graph, end of the pre-tensioned railway sleeper. This is a photograph of railway sleeper. For a pre-tensioned member, the pre-stress is transferred by the bond between the concrete and tendon. There are three mechanisms in the bond. First one is adhesion between the concrete and steel. Mechanical bond at the concrete and steel interface. Friction in pre-stressed concrete transfer compression. Now we will see the transmission length. There is several factors that influence the transmission length. These are as follows: type of tendon, wide, straight, and bar. There is also size of tendon. Stress in tendon, surface deformation of tendon, plane indented, twisted, deformed, stressed in the concreted transfer. Pace of cutting of tendon, presence of conforming, the reinforcement effect of creep, compaction of concrete, amount of concrete cover. Now we will see the composite material or composite section. A composite section is a contest of prestressed concrete member referred to section with a precast member and precast member in place of CIP concrete. There can be several types of innovative composite section, as we'll see here. This is your box section, this is composite beam section, and this is your T section. Now we will see the advantages of a composite section. It is saving in the formwork, fast track construction, easy to connect the member and achieve continuity. Analysis of composite member section or composite section, you will see this is section and that will be your diagram for stress and strain. And this image is showing the stress profile for the composite section, which you can see here. And stress in precast of wave transfer will be equal to F equals to P upon A plus minus PEC upon L plus minus MSWC upon L. That will be your formula of stress in the precast wave at the transfer. And there is also one formula stress in the precast wave after casting of a flange. It is equal to P upon A plus minus PEEC upon this. And there is also proposed construction. F will be equal to PE upon A plus minus P upon L plus MSWC upon L plus minus MCIP plus MLL is equals to L dash. Here we will see what is the meaning of A, area of the precast wave. C, distance of H from the center of gravity of precast wave. C dash, distance of H from the center of composite section. E is equals to eccentricity of center of gravity, and I will be moment of inertia of precast member, and I dash will be moment of inertia of composite section. Now we will see the MCQ question which is related to pre-stressed concrete. First question is given here. The phenomena of development of internal tensile stress in a concrete member by means of tensioning device are called. What will be the right answer here? Options are given. pre-tensioning, post-tensioning, pre-tensioning of concrete, and thermoelectric pre-stressing. Let's see, and here right answer will be C. Means pre-stressing of concrete, that will be your right answer. There is also explanation is given. As we all know, pre-stressed concrete is a basic concrete in which internal stress of a suitable magnitude and distribution are introduced so that the stress resulting from external load are contracted to a desired degree. Now come on the second question. The reinforced concrete member, the pre-stress is commonly induced by, there is option given, tensioning of steel reinforcement tendons, shortening of concrete rings. Let's see what will be the right answer. Right answer will be here A, tensioning of steel reinforcement. And there is also I written the explanation which will be helpful for all the students. And here in reinforced concrete member, the pre-stressing commonly introduced is by the tensioning of steel reinforcement while rings stirrups are used while placing a column or foundation in a structure. Tendon is a stressed member of pre-stressed concrete element which serve the purpose of transmitting the process, the pre-stress to the concrete and shortening the concrete phenomena occurs while the pre-stressing. That's why right answer here will be, as you can see here, right answer. Your right answer will be C. That will be your right answer here. Now come on the next question. Which of the following basics concept in involved in analysis of pre-stressed concrete? Option is given here: combined and bending stress, principal stress, shear stress, overhead stress. So here right answer will be A, combined and bending stress. And there is also explanation which is given here. Come on the next question. The pre-stressing concrete member is carried out by the reduced, option is given here: compressive strength, tensile stress, bending stress, shear force. And here right answer will be compressive stress. Come on the next question. The earliest example of wooden barrel construction by the force fitting of metal bands and string fitting of metal tires of wooden wheels is indicate the art of. This is the art of pre-stressing. As we all know, the right answer will be here A. The concept is used in many branches of civil engineering and building construction. Reinforced cement concrete, pre-stressed concrete, steel, lump sum concrete, and here all right answer will be pre-stressed concrete. And these are the concrete used in the field of civil engineering. Come on the seventh question. The attempt to introduce permanently acting force in a concrete to resist elastic forces, pre-stress loading, pre-stress bending. Here right answer will be pre-stressing. Come on the next question. Next question is number A. In the reinforced concrete member, the pre-stress commonly introduced is tensioning steel reinforced, tensioning wood reinforcement, tensioning rings, and tensioning plates. Here, right answer will be tensioning steel reinforcement is known as pre-stress of concrete, and in reinforcement concrete member, steel is commonly used by the tensioning steel reinforcement, and steel was used in reinforcement in the earlier days and had several disadvantages in the case of residential building. Come on the ninth question. Development of early cracks in reinforced concrete due to strain of steel, stress of steel, ultimate load bending steel. Here right answer will be strength of steel. That will be your right answer. Come on the next question and last question, which is which is here. Concrete is a weak in compression, tension, loading, and bending. As we all know, concrete is weak in the tension, and tension will be your Right answer. Come on the reference. There is a reference of building construction which is written by the BC Punamia and civil engineering material which is written by Professor. This is the reference of today's video lecture and thank you for watching this video.